Hi, this is section 12.3 and we are on the third and hopefully last video for this section. Alright, you win third place in the lottery and will receive $30,000 today and semi-annual payments of $40,000, okay, starting in 6 months. Assuming you could earn 7.5% compounded semi-annually, what will the value of your prize be in 10 years? Alright, 10 years. Alright, so let's fill out the chart. You will receive $30,000 today. So that is present value. And then semi-annual payments of $40,000. So twice a year you will get $40,000. So those are payments. And we're looking for future values, so that's what we will be computing, right? We will be finding this. Oops, scoot that over a little bit. I can't get that in the right spot very well. Okay, that might work. Okay, so we had compounded semi-annually for 10 years. So 10 times 2, so 20 times during that 10 years it will be compounded, and 7.5% divided by 2. Don't forget to put your equal signs before you put this on your calculator. Now remember, as I've told you before, you can pause and get everything in your calculator to compute your future value. I don't leave a lot of space in between that when I'm finding these. So your future value for this one is going to be $1,223,340.02. All right. Next practice question. If you deposit $50 each month for 16 years into a savings account paying 1.25% interest compounded monthly, what will be the ending balance on the account? Okay, so $50 per month, 16 years, 1.25% compounded monthly. So that's a pretty low amount of interest, really, right? It's a small interest rate. And whoops. Okay. So let's start filling out our chart. Also, notice when you type in 1.25 divided by 12 on your calculator, the screen will look like this, IY equals 0.10. But that's only showing the first two decimal places because it has rounded what you see, but what's really there is not rounded, right? The 0.10416 repeating. So just know that what you see on your screen isn't exactly what's going into the calculations, but the calculator knows how to use that number. Okay, so 16 years compounded monthly, so times 12. Our interest rate of 1.25% divided by 12. Don't forget your equals. Present value is 0 because we're paying a payment, $50 per month. The $50 per month will be negative because it's going into an account, and then we're going to compute future value. All right. So in this case, we are depositing a fairly small amount. Our interest rate is not very high, and so you'll see that this number is not quite as large as some of the ones that we compute. All right, don't forget to pause if you want to find this yourself. And it is $10,621.23. Okay, practice question 5. Nancy spends $135 a month on cigarettes and is considering the advantage of kicking the habit. If Nancy just turned 25 and deposits the $135 each month into a savings plan earning 3.5% compounded monthly, how much will she have in her savings plan 35 years later? Okay, she is 25. It's going to be $135 per month, 3.5% compounded monthly, And how much will she have in her savings plan 35 years later? So they gave us the number. We didn't have to subtract that time, although we could have, right? That's not that hard to do. You just have to look and see how the question is worded. So 35 years compounded monthly means 35 times 12. Don't forget your equal sign. And 3.5% divided by 12 equals, I can't write the division sign for some reason. And then our present value in this case is nothing, because she's not putting in a lump sum. She's simply going to pay a payment, and her payment is $135 per month. It will be negative because it's going in the bank. We are going to compute future value. So the future value in this case, don't forget to pause if you don't want to hear this yet. Okay, $110,997.86. Okay, so that was practice question 5. Here's practice question 6. All right, Jack is 27 and deposits his semi-annual bonus check of $350 into an individual retirement account twice a year. So he gets the bonus twice a year and he puts it in his account. And he's 27, but I don't think we need that for this question. So he's depositing $350 semi-annually, twice a year, and it's 5.3.75 compounded semi-annually. How much will Jack have when he retires 38 years later? So we don't really have to know the 27, but we do need the 38. Okay, so 38 years, semi-annual is the rate that it is, the times it's compounded twice a year, not the rate. The rate is 5.375%. We're going to divide that by 2, push your equal sign. The present value is currently 0 because he's just making a payment. His payment is made twice a year, $350 every 6 months, basically, right? Semi-annual. We are computing future value. So that's the number that we're going to circle for future value. And don't forget to pause if you don't want to hear this answer just yet. And it is $84,713.0 in this case, right? And so that's the answer that we have computed. Okay, last question. I'm trying to make sure I get this in a reasonable time without having to make a 4th video for this. Okay. Calculate the account balance for $800 left on deposit for 3 years, earning 5.25% compounded daily. Well, we haven't had a compounded daily yet, right? So we've got $800, 5.25% in 3 years. Compounded daily means 365 times a year, right? That's an interesting number. So we're going to say 3 years times 365 equals, and then the interest rate, the periodic rate has to be a daily rate, so we're dividing it by 365 equals. The present value is that amount that we put on deposit of $800. We are not paying a payment. And so we are going to compute, whoops, I put that on there, and then compute our future value. And let's see what that's going to be. So remember that you're not going to, you might need to pause the recording so you don't know what the number is yet. And let me put that in. Okay, so future value is 936 45. And that is, in fact, the end of the video. So we made it just a little over 10 minutes. All right, bye.